Good day everyone, welcome to Bright Engineering. Today we are going to look at mathematical induction, and this is a different form of mathematical induction. So the first one we looked at was when you were given a series form of induction, and this time around we are going to look at when you have a summation form of an induction, right? So like I said in the previous video, when it comes to mathematical induction, no matter what the question is or how difficult you think it would be, you only have to go through 3 steps. First one is the testing stage, the second one is the assumption stage, and then lastly you solve the question itself, right? So this time around we can all see that we have two different variables here, which is the n and then the r, and then we are going to look at how we go about a question like this. So step one, which is the testing stage, we are going to test this, right? So when n is equal to 1, mind you, already they've given to you here that r is equal to 1. So we are not worried about r, we are worried about n. So when n is equal to 1, we already know that r is 1. So we are getting 1 squared is equal to 1 over 6 into bracket 2 times 1 plus 1, and then 1 plus 1, right? So this one is going to give us 2. 2 times 1 is 2 plus 1, which is 3. So 3 times 2 is 6. 6 times 1 is 6. So we are getting 1 squared is equal to 6 over 6, and this 1 is equal to 1, right? So now we've tested it, and then we've seen that the left hand side is equal to the right hand side. Now when you come to the second stage, which is the assumption stage, now we have to assume that when you put a variable in, or when you change it to k, it's also going to be true for all variables, right? So when n is equal to k, we are getting the summation n changes to k. We still have r to be equal to 1, and then r squared here. So note, we didn't change the r remained the same. So equal to k over 6, because it's when n is rather equal to k, not r, right? We are getting 2k here plus 1, then we are getting k plus 1 here. So we are done with the second stage 2. Now stage 3, or step 3, which is the proving stage. This time round we are rather going to convert r instead to k plus 1 and not n, because we are saying that when we sum all these, when r starts from 1 and then it gets to k, this is what we should get, right? So now we are going from when r starts from 1 and it gets to k plus 1 instead, then what we are going to get is going to be what we would prove here, right? So this time around we are going to change r to k plus 1 instead. So when we change r to k plus 1, we are going to get r squared is equal to k plus 1 all squared, because r is squared, the k plus 1 has to be squared. Now when we have this, then we have to add this to both sides of the equations. So we are getting the summation of k, r is equal to 1 r squared plus k plus 1 squared equal to k over 6 to bracket 2k plus 1, and then k plus 1 plus the k plus 1 all squared. When you get to this stage, it's simpler with the left hand side, because you don't really have to do any much calculation here. The only thing that you have to do here is that you omit this k plus 1 squared that you added to the left hand side, and just change this k to k plus 1. So this is just showing you that this k plus 1 squared has been added to the summation, right? Because from how r looks like, it's starting from 1, so it's like 1 squared plus 2 squared plus 3 squared to k squared, and now we have k plus 1 squared, right? So we get summation of k plus 1, r is equal to 1, r squared is equal to, now we are going to solve this. So we have k over 6, and then to expand this or multiply this, we are getting 2k times k, which is 2k squared, 2k times 1 plus 2k, I have 1 times k, so plus k, and then 1 times 1, which is going to give us 1, right? Plus, now we can expand this too. So we're expanding this, we're getting k squared plus 2k plus 1, right? Good. So now we can just group like terms here and also find the LCM for this. So we are getting, can straight away multiply this one through. So you're getting 2k cube. Here, the 2 of this is going to give us 3k times k is going to give us plus 3k squared, and this plus this is going to give us k, right? Plus k squared plus 2k plus 1. All this multiplied by 6, that's when you find the LCM. Then now we can divide the whole expression by 6. So now we can expand this and then add or group like terms. So you are going to get 2k raised to the power 3 plus 3k squared plus k plus 6k squared plus 12k plus 6 all over 6, right? And when we add it, we only have one expression for k cube. So we are getting 2k cube. When we look for the k squared variables, we are getting 3k squared, 6k squared here, and now we are getting plus 9k squared. And then for the k values, we are getting k and 12k, so it's also going to give us 13k, and we only have 6 here, so plus 6, and we can now divide this whole expression by 6. Thank you very much for staying with us through this video. If it's been helpful, please don't forget to subscribe, like, comment, and then share.